Okay, I mentioned that acid derivatives are weak electrophiles, so they react with strong nucleophiles. And the example of the strong nucleophile I gave was the organometallic reagents. Well, as it turns out, hydrides also react with acid derivatives. So we're going to look at hydrides. Now, I'm going to start with an ester, but we'll move off to other acid derivatives as well. So let's take our ester and let's react it with a hydride reagent. As it turns out, sodium borohydride is not really good enough. People generally use lithium aluminum hydride for this reaction. I'm going to tip my hand. This is going to be reagent step 1, because we're going to have to add water at the end to protonate a tetrahedral intermediate. This reaction looks almost identical to the organometallic reaction that we've already seen. So the hydride attacks, we get a tetrahedral intermediate. From this tetrahedral intermediate, we're going to eject our third electronegative atom bond. Well, I guess it's a second once we attack with the hydride, but we eject our OR prime group. And we reform a carbonyl. It's an aldehyde. Well, aldehydes react with lithium aluminum hydride as well. So as soon as that forms in the reaction, the hydride finds it. We attack again. We form a new tetrahedral intermediate. Let's try to keep this on one line. Then we have step 2. At this point, the reaction's done. We form a tetrahedral intermediate. We have nothing to kick out. And so this patiently waits around until we add water. So we get an alcohol. So we can react esters with lithium aluminum hydride followed by water to neutralize everything. And we will get an alcohol. Now, technically, you can't forget the fact that we kicked out an OR group. We will also get, an OR prime group. We will also get that as the alcohol. But typically, we're focused on the part of the molecule that came from the carbonyl. You can also do this with carboxylic acids. Take a carboxylic acid and do the same chemistry. You will get an alcohol out, and that works really well. These are all reductions. We're reducing the oxidation state of the carbon. Note we're going from a carbon in the ester that has 3 bonds to an electronegative atom to a species that has just 1 bond. So we're reducing our carbonyl carbon. Now, the last reaction I want to mention involves amides. Amides are a little bit different. When we react these with lithium aluminum hydride, this is a property that comes in because of the aluminum, we don't actually break this bond, which is the bond that we broke in our ester reaction. What we end up losing, we end up pulling that oxygen completely out of the molecule. And we make an amine instead. So that's kind of a quirky thing. We won't go over that mechanism because it's different, because we're actually pulling that entire carbonyl oxygen off the molecule. But acid derivatives react with strong nucleophiles. That includes organometallics. It also applies to hydrides as well, and it's a fairly common reaction in organic chemistry.